All right, we're going to look at a bunch of different types of graphs whenever you have your and inequalities. So there's different conditions and different things that are going to happen. I suggest writing these down. So we're going to look at the first one. Ooh, that's me. That is not what I meant to do. Here we go. All right. So we have x is greater, 8 is greater than x, and x is greater than or equal to 3. Remember, if it's written together, it's an and needs to satisfy both of them. I'm going to break apart though, and I'm going to make it x is less than 8 and x is greater than or equal to 3. So I'm going to be looking for where they overlap, the parts that they share. That's also called an intersection. So we have x is less than 8, so it's going to be an open circle pointing to the left. And we have x is greater than or equal to 3, it's going to be a closed circle pointing to the right. So we just want where they overlap. So we will be erasing these little arrows and just the distance between them. So I could even rewrite that down there. So we're just looking for their overlap. So that's your traditional and inequality. That's what it will most of the time look like. So there are some circumstances where it will look different. So here it's all written together, so we know it's another and statement. We're looking for where they overlap when it's true for both of them. So we have x is less than 2 and x is greater than 5. So that means that we have x is less than 2 and x is greater than 5. Notice that this actually looks like an or inequality. There is no point where they're overlapping. So since they are not overlapping, there's never going to be a solution that is true for both of them. So this is going to be a no solution. All right, here's our other circumstance that we might run into. We have -2 is less than or equal to x is greater than or equal to 3. I'm going to rewrite it again, just so that way it's a little clear as to which direction is going to be pointing on the graph. So we have -3, -2, -1, 0, 1, 2, 3. Okay. So we have x is greater than or equal to -2. And we have x is greater than or equal to 3. So they're pointing in the same direction, and we're just still, even though this is different than our traditional and, we're looking for where they begin to overlap, and this is where they begin to overlap. This is where their intersection is. So we're going to actually just drop this because in that area, it's true for one of them, not true for both of them. So we're only going to keep x where x is greater than or equal to 3. So those are all of your strange circumstances that you're going to run into with your and inequalities.